Hey guys, in this video we're going to talk a little bit about the experiment motivation, the question, your hypothesis, the materials you're going to use, and the procedure. And so what I want you to do is I want you to, while you're watching this video, make sure that you're logged into your STEMScopes assignment, Explore 2 Scientific Investigation, Amounts Matter. Scroll through the assignment as I take you through what's expected for each portion of the experiment. Starting out, you'll have to clearly state the question that you want to answer by conducting this experiment. Our goal in this experiment is to determine whether the amount of material in a substance affects thermal energy transfer. In other words, does the amount of material make it easier to heat or cool it? In the space where you'll type your question in STEMScopes, you'll need to identify how the independent variable will affect the dependent variable. In this experiment, our independent variable, which is the thing that we're changing, is the amount of material, or water, we'll be heating up. Our dependent variable, which is the quantity that depends on us changing the independent variable, is the length of time it takes to heat up the water. Our control variables, which are the things that are staying the same among our three tests, are the stove we're using to heat up the water, the type of pot, and the starting temperature of the water. Next, you'll need to write your hypothesis. Your hypothesis is your educated guess stating how you think the experiment will turn out. How you phrase your hypothesis must directly mirror the question that you posed. So for example, if your question is, does the amount of material make it easier to heat or cool the substance? Then your hypothesis would be something like, yes, the amount of material does make it easier to heat or cool it. So a smaller amount of material would heat up faster or slower than a larger amount of material. So that's how you would phrase your hypothesis. Okay, but that's going to be your educated guess as to what you think is going to happen in this experiment. Okay, now, the materials we're using for this experiment are a measuring cup with milliliter measurements, a thermometer that can be immersed in water up to boiling temperature. So your regular thermometer that you would be using for to take your temperature to see if you were sick or had a fever, that might not withstand the high enough temperatures for this experiment. And you'll need some water, okay? You'll also need a pot and an oven mitt to hold the pot if it's hot or when it's hot. Also, this experiment must be done with adult supervision, and that is because you'll be dealing with a hot stove and water that will be nearly boiling. Okay, so make sure you have your parent or an older brother or sister who knows how to work the stove and be safe with that. Now here's the thing, you can come up with your own procedure to test your question about whether the amount of material will change how the heat affects the temperature of the material, or you can use the following procedure. Pour 200 milliliters of water into your measuring cup and make sure that when you look at your measurement that it's at 200 milliliters. So it's kind of hard for you to see with this because my video is so far away, but if you zoom in you would see that the level is at 200 milliliters. Okay. Next, you'll record the starting temperature of the water. So it is 66.5, if you look at that. So you'll record that in your data table in STEMScopes. Next, we'll pour our 200 milliliters of water into the pot, into the cold pot on the burner, and we will start up the stove, turn it to high, and we will then start our timer. Okay, so start your timer on your phone. So you want to heat the water till it's 90 degrees Celsius, which is 194 degrees Fahrenheit. So we're at 194 right now. So I stop my timer when my thermometer shows that the temperature of the water is 194 degrees Fahrenheit. Now, be careful because the heat is going to come up around the pot. And so when I was holding the thermometer in the pot, I had to actually take my hand away to be able to test the temperature again, because the water and the flame around the pot was so hot. So really be careful. Maybe use an oven mitt to hold your thermometer, and it might be a little slippery, but that's going to be much safer than having your bare hand. Next, we're going to pour 100 milliliters of water into our measuring cup. And we're going to put it in a new pot, one that's not hot at all, so that we start with the same starting conditions that we used for the last one. Okay, so you'll see that my timer is set at 0. Okay, and I'm going to turn the stove on, and same setting, so I'm using high. Just stay consistent with your setting, whether you use high, medium, or low. Just use the same setting for all of your 3 trials. Okay, sorry about the clicking of my stove. Definitely need to fix that at some point. But my starting temperature of my water came from the same little pitcher. So the starting temperature was the same as the first one. And so I'm going to actually use my oven mitt to hold the thermometer over the water, so I keep my hands safe and I'm able to see the thermometer. And I'm just, with my oven mitt on so that my hand doesn't get roasted, I am just waiting until the thermometer reaches 194 degrees Fahrenheit. And then I'm stopping my timer. Okay. So my time was 1 minute and 27 seconds for the 100 milliliters of water. And since I don't have a third pot to use, I'm just going to dump the hot water out from my first trial. Okay, I'm going to run some cold water on it and just get it back to the cool temperature, room temperature that it was before I started my trials. Okay, so I just want to make sure that I'm starting with the same starting conditions for all of my trials. So I can feel the pot now, and it's room temperature now. So I'm going to use this pot for my third trial. And for my third trial, I'm going to use my measuring cup again, and I'm going to measure out 50 milliliters of water. And my measuring cup only has a 100 milliliter mark, so I'm just going to fill it halfway toward that. Okay, toward the 100. Right, and I'm pouring that into my pot. And looks like the water in the pot doesn't quite coat the whole bottom of the pot, so I'm just going to do my best with this one. I'm going to restart my timer, and I'm going to put my oven mitt. I'm going to start my stove up to high, same setting as I've done for the other ones. I'm going to put my oven mitt on and start my timer. So I got my timer going on my computer, and I'm using my oven mitt to hold the thermometer and looking to see when it gets to 194 degrees Fahrenheit, which is 90 degrees Celsius. And at the time that it gets there, I'm stopping my timer and recording that time in my STEMScopes lab. I'm really glad I have this oven mitt on right now, because otherwise my hands would be roasting, which they did during the first one when I didn't use the oven mitt. So definitely use an oven mitt to cover your whole hand if you can. All right, we're getting up there now, getting pretty close. All right, there's our 194. And we'll stop our timer. Okay, so we're done with all our data collection now. We just want to let the water cool off naturally, and we'll go to the next step of our lab. Okay, now you have the 3 times for the 3 different amounts of water that it took to get that water to 194 degrees Fahrenheit, which is the same as 90 degrees Celsius. So you want to record those 3 times that I showed you in the video for the 200 milliliters of water, the 100 milliliters of water, and the 50 milliliters of water. So I'm going to post this data table in our weekly update so that you have that information to be able to analyze your data. So if you can't do the experiment at home or don't feel comfortable doing it or you don't have adult supervision, that's fine. You're just going to use the data that I provided you. So when you put that data into STEMScopes, what you're going to do is you're going to calculate the rate of temperature change for each volume of water by dividing the change in temperature by the time it took to heat the water up to 90 degrees Celsius. And you're going to record that rate of temperature change for each amount in your data table. And there's a space for that in STEMScopes. You'll see that in the data table. And so to calculate the change in temperature, the change in any kind of temperature or any kind of 2 numbers, you're going to do the final temperature minus the starting temperature. So in this case, the final temperature is 194 degrees Fahrenheit for all of them, and the starting temperature for us was 66.5 degrees Fahrenheit. So that's what you're going to use for your starting temp. So subtract them, you get the difference between those two, between the final and the starting amount, and then you'll divide that amount by the time it took in seconds. So for our last one, it took 1 minute and 16 seconds, so 1 minute is 60 seconds, so it took 76 seconds. So we would do the amount of the change in temperature divided by 76 seconds, and that will give us our rate. And our rate will be in degrees Fahrenheit over seconds. So degrees Fahrenheit divided by seconds. Okay? We'll go over this in class, but if you have any questions about this, definitely send me a message in Teams. All right, at this point, you're done with your experiment. You're done collecting your data. The only thing left to do is to answer the analysis questions at the end of the assignment in STEMScopes and turn it in by clicking the green Turn In button, which will submit your assignment to me so I'll be able to see it. I don't really like that there's not a graph in this one to be able to graph our results, but that's okay. I think it's important that we do the analysis and conclusion. There's no CER, there's no graph, so it's simpler than the last experiment. But your conclusions are going to be drawn by answering the questions in STEMScopes. So when you do your Flipgrid video, you're going to present your results, so the data that you collected for each amount of water, the rate of temperature change, and you're going to discuss what those mean, and so how those show whether your hypothesis was either correct or incorrect, and use that data as your evidence to support your conclusion. And so that's really it. So that's what your Flipgrid video is going to be about. All right, and I included the link to the Flipgrid video in the weekly update as well. So good luck, you got this, and let me know if you have any questions by chatting me on Teams. All right,